Let's go for lecture 23. This is the follow-up for lab 9, so which should be straightforward, so I will quickly go over it. Okay, the appropriate statistical procedure. These are the three things that we have already gone over in the class, but if you want the PDF version that I have uploaded in Canvas, then go to the module sections, and in module 3 for exam 3, please look at selecting appropriate test.pdf. Selecting appropriate test, selecting between regression, t-test, confidence interval. Okay, so regression is used whenever we want to predict one variable using another or finding correlation between two variables. Two-tailed test is used to compare the differences of averages of two subgroups of data, and one-tailed test is for finding if average of one data group is better or lesser than another average of another data group. And confidence interval, if we want to compare the average of a data group with one fixed number, then we go for confidence interval. Okay, and please look at previous videos of lab 9 and lecture 22, and things will be much more clearer. Obvious issue and the hardest task for a student is how to choose the appropriate statistical procedure. Traditionally, textbooks avoid this issue, for they typically assess the students in a way that is very easy to determine which statistical procedure is needed. That is, after regression was covered, the students were tested on regression. After confidence interval were covered, the students were tested on confidence interval. To make things even worse, many of these assessment packages actually inform the students which procedure to use, either t-test, regression, or confidence interval, etc. However, in a real world, hardly ever, if ever, does one encounter such a situation. When management install new TV sets in restaurants, they do not ask you to perform t-test in order to validate their investment. No, they just ask you to perform the appropriate statistical procedure. Distributing flyers in order to increase the sale is a well-known marketing strategy. Sometimes it works, sometimes it does not. Given the sales data, it is obvious that your supervisor would like to know if flyers worked, but it is highly unlikely that he will ask you to perform regression analysis or any other test. Instead, he will ask you to perform the appropriate statistical procedure. So that's why it is quite relevant that we need to go over this rule of thumb. Okay, labs 8 and 9 were designed in order to mimic real life situations, and although you have probably found the task a bit more difficult than the usual ones, you should not panic. We have presented the questions from lab 8 and 9 to many seasoned engineers, accountants, and even university lecturers, and many of them had hard time answering correctly. Okay, so rules of thumbs for choosing a method. Regression, we need two variables, two data sets, and question if variable X is influencing variable Y. T-test, we need two variables, two data set, and the question is if the average of one variable is different than the average of variable Y. If the question is about the difference of averages, we use two-sided, otherwise we use one-sided. Okay, so look at the PDF that I have posted in online. Confidence interval, we need one data set, and the question if average of this data set is different, either larger or smaller than a fixed number. In what follows, use any following test procedure: regression, confidence interval, one-sided, two-sided, t-test. All procedures should be done with 5% p-value or 95% confidence interval. So let's go for math credit salary data. It is believed that more math credits a student take during their college years, the higher their salary will be. So math credits increases the salary. Okay, higher math credits, higher the salary. That means one variable influence another variable. Given the data, your job is to confirm or disprove this assertion. Which test procedure? So if one variable affects another, or if we predict one variable from another variable, then we go for regression. What is the p-value or margin of error? Here I have uploaded the math credits salary data, and the salary is in 1000, and math credits that the person took in college is given in column A. Let's go for regression. So that would be data analysis, regression. Okay, salary is determined by math credits, so let's go for this one. For y variable, for x variable, that's independent. Click on labels. Okay, then we can see that the p-value for this thing is simply 0.00166. So the p-value is 0.00166. Write one line in statistical interpretation. Since p-value less than 5%, so it says p-value is very low, less than 5%. So we can confidently claim that variable X math credits influences variable Y. That means, so we are quite certain that there is a relation between math credits and salary. Okay, write one line conclusion in the future. Yes, so we can confirm the claim that more math credits equals more salary. Use the same math salary data in task 2. Is it reasonable to claim that people who took more than 10 math credits will have average salary of 43,000 or more? Come up with all the students and their salaries who has obtained 10 math credits in the college, and let's see what happens. For this one, let us go to home and sort and filter, custom sort. Okay, sort by the math credits taken. Okay, thus we have this many people from 23 up to 36 who obtained more than 10 math credits. Okay, and moreover we are comparing the salary. Okay, so let me color it. Then here it says that, is it reasonable to claim that people who took more than 10 math credits will have an average salary of 43,000 or more? We have already chosen this data, so these many peoples, okay, who took more than 10 math credits earns this much figure individually. Okay, now we want to compare the average of this data with 43,000. Okay, so that means we are comparing the average of a set of a data, this set of data, with a fixed number 43,000. So that's why we go for confidence interval. This is quite tricky, right? This is a bit tricky. Although the given data contains 2 columns, we are asked to compare the average of one particular data set, that is salary of all the people that took more than 10 math credits, with one particular number, 43,000. Now let's go for margin of error for this one. So average for the data set is $48.428,000. Okay, standard deviation equals STDEV. The set of data is from here to here, bracket close, enter 9.027. So margin of error is equals confidence dot t, start with alpha to be 0.05 since we want 95% confidence interval. So 9.02 comma, there are 14 people, so margin of error is 5.212283. So now let's go for confidence interval, which is equals, for the left endpoint of confidence interval we subtract the margin of error with average. Margin of average is this one, average is this one, so that would be 48.428 minus 5.2122. Left endpoint is 43.21, right endpoint will be equals 48.428 plus 5.21228. So 53 is our right endpoint. These numbers are all counted in terms of thousands of dollars, so we would consider that this is 43,215 and this is 53,64028. Confidence interval is from $43,215 up to $53,640. Alright, so what is the p-value? That's 5.21228, or margin of error, right? Write one line statistical interpretation. So the CI, confidence interval, is 43.215 comma 53.640. So the confidence interval is $43,215 up to $53,640. The confidence interval. Okay, so that's our conclusion, one line statistical interpretation. And so that's fine. So first we make the confidence interval this one. Observe that the whole interval is above this one. Okay, So that's why I wrote down $43,000 is less than this interval, or this interval is greater than this one. Okay, thus we can confidently claim that average salary for this group is larger than 43,000. Okay, now write one line conclusion that 95% confident we can say that average salary is more than 3,000 for the pupils more than 10 math credits. Yes, with 95% confidence we can say that average salary is more than $43,000 for pupils who has taken more than 10 math credits. Or simply, yes, it is reasonable to claim the above statement. Open pre-law nursing. Do nursing and pre-law measures have different salaries? Nursing and pre-law measures have different salaries. So we are comparing the average of nursing data and pre-law measures data. So we are trying to find the difference between these two subgroups. Okay, so we would go for two-tailed t-test. Sided t-test is used because we are clearly asked to see if the average salary is between these two measures are different. Okay, I have opened the pre-law nursing data. Let's assume that this is thousands of dollars. Okay, these all are thousands of dollars, and here we need to go for two-sided t-test or two-tailed t-test. So equals t-test. The first one is the first array, this one, and the second one is second array, which is this one for the nursing data, comma 2, that's for two-tailed test, comma 3, that's for p-value. Okay, p-value is 0.000629. Okay, 0.00269. So here I was mistaken that I should have written 0.000629. Instead I wrote 00269. So yeah, our p-value is correct. What is one line interpretation? Since p-value is less than 5%, so we are quite confident that the average salaries are different. We can write there is a significant difference between the average salaries. So the salaries for nursing and pre-law measures are indeed different. Okay, that's fine. Now weight versus IQ. Task 4, open the weight versus IQ data. The setup, it is reasonable to assume that IQ and weight of a person should not be related. Given the data, your job is to check if this assertion is indeed reasonable or not. So here we need to see whether IQ and weight is not related. That means this is a case where one variable is influencing another, or one variable predicts another, or relation between two variables. That means we need to go for regression. Regression, why? Because the question is about a relation between weight and IQ. More precisely, we are asked if weight is influencing IQ. So let's go for that. Here I have uploaded weight versus IQ data. And since this is the case of regression and the variable weight influences IQ, here we are trying to see whether the weight, this variable, influence the IQ variable or not. We should predict IQ. Okay, so let's go for B1 up to B29, sorry, B30, and X variable is weight, which is from A1 up to A30. Click on levels and click on OK. P-value is 0.7499, which is a very, very, very large p-value. Okay, that's nearly 75% p-value. Okay, then this is 0.7499. Since the p-value is larger than 5%, so there is very less influence of. So statistical interpretation, since the p-value is large, we cannot claim that there is a significant relation between these two variables. Okay, that's fine. So we can write in one line conclusion, yes. Okay, so we do not have any statistical evidence that weight and IQ are related. So that's quite reasonable to assume that IQ and weight of a person should not be related. That's all.